Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome everyone to lecture 5 in ITDR2103. Today's lecture shall cover about the discrete probability theory, and we will start by defining the basic terminologies in probability, how we can find a probability, and finally we will check the odds of favor. Alright? So in order to understand the probability process, I need to identify some terminologies in this topic. First of all, we need to have an experiment. So experiment is where the process by which our observation is made. So for example, our experiment here is tossing a coin. All right? So if I tossed a coin, then I should have something called sample space. And the sample space is all possible outcomes of the experiment, and it might denote it as S. So in case I'm tossing one coin, then my sample space is either I will get head or tail. In case I tossed two coins, then I might get head head, head tail, tail head, or tail tail. So we call this all the possible outcomes as a sample space. Now each element of the sample space called as sample point. All right, we have something called an event, which is a set of consisting of possible outcomes of the experiment. So let's suppose I am in the experiment of tossing two coins. All right, what are the events of getting at least two heads? So this event says what are the possibility of getting at least two heads. If I go to my sample space, the only possibility of getting two heads is head. All right, so here we've got an event. Event is merging the sample point with a specific condition. Okay, then we've got something called discrete sample space, which is a discrete is one that contains either a finite or countable number of discrete sample space. So here we've got the discrete sample space. All right, we've got a countable number of discrete sample points. All right. In the events part, I have type of events here. First type is simple event, where the event cannot be decomposed, which each simple event consists of only one simple point. Something look like our event here, which is getting at least two heads. So we consider this as simple event. Why? Because it consists only one sample point. All right? Okay. Compound event is the opposite of simple event, which means that I have an event that can be decomposed into more than one simple event, and we call as compound event, and we will see an example on the next slide. Complementary event is if I have A as an event connected with a probabilistic experiment E and S be the sample space of E, then the event B of non-occurrence of A is called a complementary event A, something like A complement, which is all the events that occur in the sample space and not in A. And again, we will see an example to understand more about those events. Okay, example here says, consider the experiment of throwing single balanced die, all right, and recording the number on the top faced. Now we need to find those events. All right, what are the events of having an even number? So here, having an even number is, before I'm getting those events, let's just introduce our sample space for this experiment. So the sample space here is, if I throw the balanced die, I might get 1 or 2 or 3, 4, 5 or 6. So these are the possible outcomes of the following experiment. Now, what are the possible outcomes of getting an even number? I've got here 2 or 4 or 6. All right. What are the possibility of getting less than 4? Number which is less than 4. I've got here 1, 2, 3. Right? Then, what are the possibility of getting a prime number? It might be 1 or 2 or 3 or 5. And all we know that prime number is the number that does not have a factor except 1 and itself. All right? How about getting 2 or 5? It be either 2 or 5. The event of getting 1 is equal to 1. The event of getting 2 is equal to 2. And the event of getting an odd number is equal to either 1 or 3 or 5. Here we found the possible events. Now let's match those events with the events type we says in the last lecture, in the last slide, sorry. So we consider E and F as simple event because I cannot decompose those two events, and those events consist only one sample point, right? So E and F consider as a simple event. If we saw A is a complementary event of G. Why? Because in the occurrence of odd number is possible to I have an even number. So the occurrence of one event cannot be in the other event. If I'm looking for even, then it's impossible to get an odd number, and the vice versa. All right, then we left with B, C, D, and we consider those as compound event where I can decompose the event. Also, A and G consider as a compound event. All right. Let's check this example. Suppose that a coin is tossed 3 times. Find the following event. All right? It's like I got one coin and then I tossed in the first time. So I might get either head or tail. All right? Then we tossed the coin again, so I might get either head or tail, and here also either head or tail. Again, the coin will be tossed for the 3rd time, so here we might get either head or tail, head or tail, head or tail, and head, or tail. So before we just identify all these events, I need first to find my sample space, which is S. So here we got that I can have as head, 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 or head, head, tail, following those three. So here we finish with the first probability. Then we got either head, tail, head, or head, tail, tail. So done with this subtree and done with head. Then it might be tail, head, head, or tail, head, tail. It's really important you go one by one so you won't forget any possible outcome. Then it might be tail, tail, head, or tail, tail, tail. And we are done with all possible outcomes. If you notice here, my sample space is 1, 2, 3, 4, 5, 6, 7, 8. So I've got the S number of elements in. The set is 8, which is equal to the possible outcomes on the number of repeating the experiment. So A, what are the all the three events are head? Okay, now here we can say that A is equal from my sample space. What are the outcomes where I've got all the three events are head? So here we got head, 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 only one element, only one sample point. Okay, B, exactly 2 toes are head. So here the event B is I need to have exactly 2 toes head. So here we've got 1, 2, 3. So in the second event I might get head, head, tail, or head, tail, head, or tail, head, head. Okay, finally, what are the possibility of getting at least how many? At least 2 toes are tail. So at least means it might be 3 or T, T, H, or T, H, T, or H, T, T. So at least I have 2 tails. So it might be T, 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 H, T, H, T, or H, T, T. So here we've got 4 possible in this event. Okay, another experiment is here. How about if we have 2 6-faced dice are rolled and the number rolled are recorded? Now to find the sample space of the following events. I've got an event. I need to find first, in order to find those events, my sample space. So the sample space of this event is, if I throw the 2 6-faced, I might get the first die 1 and the second die 1 on the top. Or it might be 1, 2, or 1, 3, or 1, 4, 1, 5, or 1, 6. Or I might get 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. Or it might be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Or I can have the first one 4 and the second one is 1. Then 4, 2, 4, 3, 4, 4, 4, 5, and 4, 6. Or it can be 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, or 5, 6. And finally it can be 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So this is my sample space, and if you notice here, we've got how many elements in my sample space? I've got 6 to power 2, which equal to how many? 36. Yeah. Okay. Now, what is the possibility of getting the first die shows 2 and the second die shows odd number? So here E is equal to the first die 2 and the second die is odd number. So it might be 2, 1, 2, 3, or 2, 5. So this is my event. How about the event that both dice shows the same number? So here we might get 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, or 6, 6. Alright, how about getting the sum of the number is, we already solved this one. Here, how about getting the sum of the number is 9. So it might be 3 and 6, 6 and 3. So if I add those two numbers, I get the 9 as the result. Or 4, 5, 5, 4. And that's it. How about getting the product of two numbers is 40? If you notice, the highest number in the die is 6. So the possible event of getting the highest product in this experiment is 6 times 6, which equal 36. And if you notice here, 36 is less than 40, then there is no two numbers multiply by each other and getting the result 40. So here A is an empty set, or phi does not exist. All right. In an experiment, two or more events are said to be equally likely if, after taking into consideration all relevant evidence, none can be expected in preference to another. For example, if I am hosting a fair coin, then the simple event H and simple event T, which represent getting head or tail, they are equally likely events, because if I get tail, then I cannot get head at the same time. All right, so we call head and tail as an equally likely event. Also, in throwing a ballast die, so the simple event 1, 2, 3, 4, 5, 6 consider as an equally likely event, because if I got 2, then I'm not able to get any other number, only one at a time. Now, in order to find a probability of an event in an experiment, then I can use this formula here. So the probability of E is equal the number of elements in E over the number of elements in the sample space. Or we can say this, that is equal to want over can. What do you mean by this? Let's consider the experiment of throwing a single ballast die. What is the probability of getting the number of the top face as? The number on the top face is an even number or is an odd number. So before we found the probability of getting even number or odd number, I need first to find my sample space. So the sample space of this experiment where throwing a single balanced die is equal to, I might get 1, 2, 3, 4, 5, and 6. So those are all the possible outcomes for this experiment. So here the number of sample points on the sample space is equal to 6. This all what I can get from the following experiment. Now, in order to find the number on the top face is an even number, I need first to find E. So E is equal. All the possible even numbers are either 2 or 4 or 6. So the number of sample points in this event, which is E, is equal to 3. Now the probability of E is equal to want over can. What do we mean by this? What I want is having an even number. So either 2 or 4 or 6. So how many sample points in my event? They are 3. Now all the possible outcomes or what I can get from this experiment is either 1 or 2 or 3 or 4 or 5 or 6, which equal to 6. Alright, now 3 divided by 6 is equal to 0.5. So 0.5 is the probability of getting an even number. Okay, how about the number on the top face is an odd number? So O, the event here is I might get 1 or 3 or 5. So the probability of getting an odd number is equal to want over can. So here what I want is an odd number, so all the elements of odd number, and what I can is all the possible outcomes in this experiment. So here we've got 3 over 6 and also equal to 0.5. In case I have got two events, which is E and F, and they are in a sample space. Now, if E and F are said to be mutually exclusive events, if E does not have any common factor with F, so E intersect F is equal to phi, which means they cannot occur simultaneously. For example, having those simple events, which is 1, 2, 3, 4, 5, 6, connected with the experiment of throwing a die are mutually exclusive events. So 5 intersect 6 is equal to 5. No factors are common between those two sets. Therefore, we call those as mutually exclusive events. Alright. Now, we saw this note, which is the probability is the number of favorable cases on the total number of cases, or what do we call? Want over can. So, the number of possible favorable cases means the number of ways the event can occur on the total number of cases is the number of the elements in the sample space. Alright, let's see this example here. We need to find the possibility of getting a random marble from 4 red, 6 blue, 7 green marbles in a bag. So the bag contains a total of 17 marbles. Alright? Now, the probability that I'm getting a red marble is equal to what I want red marble. So how many number of red marble in this bag? I've got 4. The total number of the marbles in this bag is 4 plus 6 plus 7, which equal to 70. So the probability of getting a red marble is equal to 4 over 70. How about the probability of getting blue marble? So what I want is blue. Number of blue marbles in this bag are 6. What I have is 17 marble. So the probability of getting one of these 6 blue marbles from this bag is equal to 6 over 17. This is my probability. Alright? How about the probability of getting either blue or red? So I have how many I can do here? I either get one of the 6 marbles blue or one of the 4 red marbles. However, what I can get is the 17 one. So here we've got 10 over 17, and this is my probability. Okay, so we got here a theorem. Says that let S be a finite sample space such that all outcomes are equally likely, and ENF be an event in S. So the probability of phi, which is not getting any sample point, equal to 0. This event is not there, does not occur. The probability of S, which is all the sample space, is equal to 1. Now the probability of any event from this sample space is between 0, no occurrence here, or 1, full occurrence. Alright? The probability of E complement or non-occurrence of E is equal to 1 minus the probability of E. The probability of union between event E and F is equal to the probability of E plus probability of F minus the intersect between E and F. So here we are avoiding the repetition. The probability of E difference F is equal to the probability of E intersect F complement, which equal to the probability of E minus the probability of E intersect F. So all these theorem can be used in the further examples ahead. Okay, here we go. We got an experiment that consists of forming license plates consisting of 3 letters followed by 3 digits with repetition allowed. First, we need to find the probability of the event E that the license plate begins with letter A, and then we need to find the other probability. So first of all, in order to solve this problem, we need to find my sample space. So the sample space, all the possible outcome of this experiment is I might get, first of all, we have 3 letters followed by 3 digits, and repetition is allowed. Okay, so how many possibilities I have to fill the first letter? I've got 26 times the second 26, the third 26. Then I've got 10 digits, 10 times 10. So here my sample space is equal to 1757600. All right. Now A is the probability that the event E is on the license plate begins with the letter A. So I have in the first letter of this license plate should start with A. So here I've got only one letter to fill the first letter. Then I can fill with any letter of 26, any letter of 26, any digit, and any digit, and any digit. So here we found that A is equal to 676000. Now the probability of E is equal to want over can. So here we found that I got 1 times 26, 26, 10, 10, and 10. And my sample space is 26, 26, 26, then 10, and 10, and 10. So here, all of these will go over here, and then we left with 1 over 26. So this is the probability of having a license plate begins with A. Now, what is the probability of getting a license plate begin with vowel and ends with an even number? So here we have my license plate, which consists 3 letters followed by 3 digits. Now the condition here says that it should be in the first place. The first letter should be a vowel. So the possibilities I've got here to fill the first letter is either A or U or E or O or I. How many letters I can fill the first place? 1, 2, 3, 4, and 5. Then any of 26 letter and any of 26 letter. Then any of digits, and then I have another condition here. The condition says it should end with an even number. The possible even number that can fill the last digit in the license plate is either 2, 4, 6, 8, and 0. So here we got 1, 2, 3, 4, and 5. So here I've got 5 possible outcomes. All right. This is the number of elements on the event F. Now the probability of having this license plate is equal to want over can. So here I've got 5 times 26, 26, 10, 10, and 5. And my sample space was 26, 26, 26, 10, 10, 10. So this will goes with this, 5 with 10. Then I left here 5 over 26 times 2, which is equal to 5 over 52. Hope everything is clear. Now let's move to the basic probabilities of probabilities. Now let's suppose weighted coin is tossed and the chance of getting a head are 65%. Then the chances of getting a tail are 35. Here we got that the probability of H is equal to 0.65 and the probability of tail is equal to 0.35. Now all of us knows that the sample space of tossing a coin is either head or tail. If I add the probability of those all the possible outcomes of my experiment, then I should get at the end 1, which is equal to the probability of S. Alright, in case I've got the sample space with sample point with k outcomes, then the probability assignment to the outcome is an assignment of real number. Alright, so the probability of a sample point in the sample space should be between 0 and 1. And I represent the number of the sample point. Adding those probability of the sample point should give me at the end 1. Okay? If Pi is the probability of outcome Si, then we write Psi is equal to Pi. For example, I've got an experiment with 5 outcomes. So my sample space is S1, S2, S3, S4, and S5. Now let's suppose the probabilities of the outcomes are given by following table. So the probability of accuracy of S1 is 0.05, S2 0.35, S3 0.1, S4 0.3, S5 0.2. Here, if we notice that all the probability of all the sample point in the sample space is between 0 and 1. And if we add all the probabilities together, I'm getting the 1 at the end, which is a probability assignment. Okay, let's suppose I got here a sample space with sample points from 1 till k. Alright, this is a sample space of an experiment, which the probability of Si is equal to Pi, and I is from 1 to k is a probability assignment. Then the probability of E is defined by the probability of E1, E2, E3 until Et. Okay, here is the example that explains the definition. Die is rolled, which the probability of getting 1 is equal to 0.10. The probability of getting 2 is equal to 0.15. Getting 3, 0.2. 4, 0.1. 5, 0.25. And 6, 0.2. If I have the event is equal to 136, then I need to find the probability of A. So we say that the probability of E is equal to the probability of 1 plus probability of 3 plus probability of 6. So the probability of each sample point in this event. So the probability of 1 is 0.10. P3 is equal to 0.2. P6 is 0.2. So the probability of E is equal to 0.5, which is the half of my sample point. Here we got the theorem. For example, ENF is an event in a sample space. Alright? Then we already saw those earlier, which is the theorem that we saw earlier. Here we got one new theorem, says that union of more than 2 events is equal to the probability of first plus second plus third, then the intersect between first and second minus intersect between second and third minus the intersect between first and third, and plus the intersect between all of them. Okay, now all these theorems are not for memorizing, it's for using. As much as you use it, as much it's stuck in your mind. Here is the example that you can see we can use those theorems. If E and B are an event in the sample space such that PE is equal to 0.53, PF is equal to 0.48, and P, the intersect, is equal to 0.22. Now, in order to find the probability, Now we say that the probability of union E and F is equal to probability of E plus probability of F minus the intersect, which is E intersect F. So here we got the probability of E is 0.53 plus the probability of F is 0.48 minus the intersect, which is 0.22. So if we add those two numbers, minus 0.22, I'm getting at the end, this is equal to 0.79. Okay, how about the probability of E intersect F complement? This is equal to the probability of E minus the probability of the intersect. So this is equal, probability of E is 0.53 minus the intersect is 0.22, which is equal to 0.31. How about the probability of E complement? We say that the probability of E complement is 1 minus probability of E, which is equal to 1 minus 0.53, and we got as equal to 0.47. Finally, the probability of E union F complement. So this is equal to 1 minus the probability of E union F, which equals to 1 minus, we already got the union in the first question, which is equal to 0.79. So 1 minus 0.79 is equal to 0.21. And here we reach the end of the first session. We'll see you inshallah in the next session.